That I got it, but using IP 172 dot yeah 172. Okay,
Each 40,000.
each 40,000. Then what do you get? 2 raised to 16. Then you can't do the subnetting here. How? ಹೆಂಗ್ ಮಾಡ್ತೀವಿ? ಹೆಂಗ್ ಮಾಡ್ಬೇಕು?
The tool ಅಲ್ಲಿ
2 raised to 16 ಅಂದ್ರ
65.
16 ಎಲ್ಲ ತಗೋತೇವ ನೀವು.
ಹಾ.
ಮತ್ತೆ 00 ಹೆಂಗೈತಿ?
ಆ ಪೂರ ಎಲ್ಲ ಆಪ್ಷನ್ ಹಾಕೊಂಡ್ರಿ ಇದ್ರ ಪೂರ ಇವು ಎರಡು ಇದನ್ನ ಆಪ್ರೇಟ್ ಬರಲ್ಲ ಸರ್, ಎರಡು 0 ಹಾಕಲ್ಲ ಸರ್, ಎಲ್ಲ
0 ಅವ್ರು 1 ಆಗ್ತಾವ.
ಹಾ ಸರಿ.
ಮತ್ತೆ ಹೆಂಗ್ ಆಗ್ತೈತಿ?
ಕನ್ವರ್ಟ್ ಮಾಡಿಲ್ಲ ಸರ್,
ಹಾ?
ಕನ್ವರ್ಟ್ ಮಾಡಿದ್ದು ಸರ್ ಅಲ್ಲಿ ಒಂದು ಪೂರ ಈ ಡೇಟ್ ಎರಡು ಐತಿ.
ಹಂಗಲ್ಲ, ನಿನಗೆ ಎಲ್ಲಿ ಸಿಕ್ಕು? 40,000 ಸಿಕ್ಕೋನದ್ರವಾಗ ಎಲ್ಲಿ ಸಿಕ್ಕು?
2:16 ಅಂದ್ರೆ ಸರ್ 65,536 ಅದ ರೀ. ಅದ್ರ ನಾವು 40,000 ಅಪ್ಡೇಟ್ ಮಾಡ್ತೇವೆ. ಸೊ ಇನ್ನೊಂದು ನೆಟ್ವರ್ಕ್, ಇನ್ನೊಂದು ಡಿಪಾರ್ಟ್ಮೆಂಟ್ ನಾವು ಇನ್ನೊಂದು ನೆಟ್ವರ್ಕ್.
You did it. Give it to me. Show it to me. Yeah, it is right. Yeah. Got confused. One. We can get it. Sorry, I got confused. Yeah, that is correct. But one thing ಮಾಡಿದೀನಿ last update ನಾಗ ಇಟ್ಟಿ. It's okay. I'll tell you. Yeah, 2 raised to 16. What is 15? 32,000. Okay. So 2 raised to 16, 65,536. Okay. And my default, what do you call, subnet mask is? Okay. Now network. Okay, remaining all I should keep it as what? Okay, it will be same, it will not change. Okay, because I have to keep 16 host bits. So already we have 16 host bits. Then block size will be yeah. One 172.16.0.0. This is a network. Okay, if we add one, next network will be 172.16.1.0. Yes, the previous will be like Mm, we got it here. 65,536 addresses in one network. Again, if you add one, we'll get next network 172.16.2.0, and the last will be 172.16.1.255. Okay, again you got 65,536. Okay, like this you can get 4. Am I clear? And in the same way, you got the same Murali. It's different. How?
172 dot 17
That is network, right?
अगले मैं लिखा था ना 65,000 का मैं बेहतर नेटवर्क हूँ
Yeah, it is getting 255. Yeah. Yeah, exactly. We have to get 17 here.
इसका वाला फिट है
17, this should be, yeah, sorry. It was 0. Okay. 172.17.0.0. Okay. Here also it will be like 172.17.255.255. Okay. Here 172.18.255.255. The last one is 172.19.0.02, 172.19.255.255. Okay, so there you will get, sorry. Okay, so that was the thing. Yeah, got it? No, 0.1. Last is 172.16.255.254. Okay, in between these two, we can have 65,000. Understood?
minus
Hmm?
256 minus 250 करना है
समझा नहीं?
मतलब सर इधर 255 तो नेटवर्क का है इसके तो इसमें बोला वहाँ पे 255 से कम हो तो फिर 56 में से माइनस करना
255 या 255 से कम हो,
तो मैं
हाँ, ठीक है.
but the bank was made 65,534 so they were getting 55,530
2 raised to 16. 2 raised to 16.
2 raised to 16 yeah
How much?
65,530
Huh?
the maximum rate is 534
5?
34
34.
65,530 yeah minus
I didn't get your question.
no, sir, that maximum is maximum range, like maximum number of we can keep is 65,500.
Class B. Class B are talking. Again, minus this network and broadcast access. Maximum is 65,536. Okay, but the valid IP addresses that we can assign it on the host devices, that is 65,534. Okay, understood? Any other? You got it, everything? Sorry? अरे हमारे पास नेटवर्क सॉरी होस्ट बिट्स कितने हैं सभी नेटवर्क्स में? होस्ट बिट्स कितने? 16 है. 16 है तो कितने हो गए? 2 रेज़ टू 16. तो एवरी नेटवर्क में कितने हो गए? तो 40,000 सेटिस्फाई हो जाएंगे ना? हो जाएगा? So you solved this VLSM? You got it? You got it right? Sure. Okay. So you want me to explain it again, or that will be okay if I go for the next topic? Sorry? That's what I want to ask you. Like, you want me to explain it, or you want me to go for the next stuff? Okay. But you got it right? 80,000. You got it? Yeah. That was 10. Requirement what? And what you will get? Two power tables? What is that?
1,31,072.
1 lakh?
31,070. 31,072.
131? You obviously will get. I don't think I need to explain. Okay. So obviously, like the default will be 3 octets will be for the host. Okay. Next, en. How many I have to keep? Again, enter. Okay. So 8 plus 8 plus 1. Okay. And remaining? Block size will be done. So in a obviously if we are keeping 17 host bits means obviously we'll be getting 1,31,072 IP addresses. Okay. So if you want me to do that, the network address will be 10.0.0.0. Okay, because we have 255.254.0.0. Okay, that means only first octet will be going for the network. Okay, next we have to add in the second octet. Next subnet will be okay. So 17, then in a single we are going to get how many? 1,31,000. Then 80,000 is you'll be satisfied. Got it? Sure. समझला? Good. What happened? Did you get it? Any question? No? Can I go for the next topic? Yes, Shaji. Sure. VLSM. Oh, VLSM, it's done, right? Okay. The one I given as a homework. Okay. It was class B. Class B. Okay. HR class B. HR 1,500. IT 3,000. Sales 1,000. Accounts 800. $100. 1,500 to get 1,500. 2 raised to 11. 2 raised to 11 minus 2, that is 1,500. Okay, what is 2 raised to 11? 2,048. Yeah. Directly block size, or you want me to write it everything again? डायरेक्ट लिख दूं? समझ में आ रहा है कुछ धीरेश? मुझे लग रहा है आपको समझ नहीं आ रहा है, आपको और उसको, आपको भी ए वाला
सबनेट बारह की है अब एस बिट ना जैसा यार हम बड़ी वेट
याद है?
एक सबनेट 12
बड़ी बड़ी
बड़े वेट
Okay, listen. What is the IP address I have given? Okay, according to this, the subnet mask will be done network. Okay, and this will be converted into then how many I have to keep? 11, 8, 9, 10, 11, and remaining 5 should be converted into network. Okay, so that will be n 1 1 1 1 1 0 0 0, and remaining should be done. What will be the new subnet mask according to this one? 255.255.248.0. Restore to 48. Okay. Next, the block size will be 8. Okay, that is for the first requirement. Second requirement, requirement is what? 2 raised to 12. What is that? 4096. 4096. Done. And 4094, that is more than enough for this 3000. Done. Next, again the same thing, but what you will get here, one more will be made as a 0. So what will be the new subnet mask? You want me to write it again? This is a default subnet mask, and then if you want done, and I have to keep 12, 8, this 4. Okay, so these all will be the host part, and remaining done. So 255.255.240, and block size will be 16. Done. Good. For the next, 2 raised to h minus 2 greater than equal to requirement, and my requirement is what? 1000. Okay. 2 raised to 10, 1024. Am I right?
Yes, sir.
Minus 2. That is more than enough. Then Next, default gateway, sorry, default subnet mask 0.0, and then convert them, I mean, those host bits into network. How many have to convert? Great. 8 and 2. Okay, 10. So up to this, all will be host, and remaining should be converted into network. N.N 11111100 dot all zeros. Done. And what about the new subnet mask? 255.255.252. Great. And the block size will be 4. Next also we are having same. Okay, so I'll not write it. You want me to write it? Sure. Then the network address will be 172.16.0.0. Okay, because we don't have any 255.255.255.0. Okay, all are having less than 255. Understood? Now, what you have to do? You have to add the 8. Okay, in the third octet. Yes. Did we get 3000? Sorry, 1500? Did we get it? How? We have 0 to 0 network, 0 to 255. I mean 0.255, 1.02, 1.255, 2.02, 2.255, 3.02. Like this, how many we have? 8. Okay. 8 into 256. How much? Obviously, we'll get 2046. Okay. So that is more than enough. Next, we have to add the 16. If we add 16, mm-hmm. 24, sure. 172.16.23.255. Okay. Are we getting 3000 IP addresses? Yes, obviously we'll get, because we are using the network between 8.0 to 23.255. Okay. If you have time, you can calculate it later, how we are getting this 3000. Okay. Because we'll get how many? 4094 IP addresses. That is more than enough. Next, we have to add 4. Okay. Plus 4, we'll get, how much will get? 172.16.28.0. And that will be broadcast for that one, 172.16.27.255. We have only one network, sorry, 3 network here. Okay, then we'll be getting 4 network, right? Yeah, 4 network, 24 network, 25 network, 26 network, and 27 network. Okay, so each having 256 IP addresses. That is nothing but 1024 IP addresses. And the same goes for second one, the last one. That is, and just add 4 then again, 172.16.32.0. So here add 4, and it will be like 172.16.31.255. So here also we are having 4. 28 network, 29 network, 30 network, and 31 network. So we are having 4 networks. Yes. So that means obviously we are going to get 1024 IP addresses. So that is satisfying the account department. Am I clear? Everyone? Sure. So what will be the slash values? Can you just tell me for every network?
For HR 21.
For HR, it is 16 plus 5. 21.
For IT
21. For IT?
20.
20. 16 plus 4. Are you getting what is network? What is CIDR value I'm writing? Yesterday also I explained it, right? The number of network bits. CIDR nothing but what? Number of network bits what we have. And I already said you, nobody talk about subnet mask in the actual enterprise network. Everybody will give you CIDR value. So based on that, you have to understand what is the subnet mask of that one. Understood? So what is the subnet mask here? What is the new subnet mask we got? 255.255.248.0. Okay. In this subnet mask, how many network bits we have? You can see here. We have N. N means what? 8 bits. And here 8 bits. And how many we are converted into network bits here from host? 5. Okay. So 8 plus 8 plus 5. How much? 21. Okay. And here 8 plus 8 plus 4. 20 obviously. Okay. So that is 20. And here 22 because we have 6 there. So here it is 22 and here also 22 and last network also will be having the same. Am I clear? Sure. Yes. Online.
Yep, I'm fine. Just one doubt, okay. 1,500, 3,000, 1,000 and 800. I just took it like I started with 3,000, then I went for 1,500, 1,800. Is there any like order which we have to follow, or is it okay that we can choose the order which the way they given the question?
You can take any order.
Okay, fine.
Yeah.
Thank you.
If you want any order, like then you can go with the least one.
Yeah, like
Account.
800.
Yeah. Then you can go with the sales, and then you can go with the HR department, and then you can go with the 3 IT.
Okay.
Okay.
Small to big.
Yeah.
Okay.
Mr. Bosu and Vaishnav, any question?
No.
All clear? Yeah, submitting is done. Sure. Great. Shall we go for next one? The switching I'm going to start now. Okay. So before starting the switching, okay, I want to introduce this the tool what we use here. Okay, that is Cisco Packet Tracer. I hope you downloaded. You did. When you're going to do? Today. Today is a good muhurta. Have you seen? You can download it. Okay. And this is how it looks like. And this is with the tool that we are going to use it for the lab. Whatever the lab you are going to do on CCNA, in CCNA, we're going to use the same simulation tool. Okay, which is having very few features that don't support a lot of the features. Okay, like the GNS3 and EVNG2. But this is more than enough for the CCNA. Understood? Okay. Now what you can see here, this is what the Cisco Packet Tracer window, what you can see.
Arun,
Yes, Mr.
if we came physical lab also, we'll use the same tool or
In physical, we have physical devices here.
okay.
But the thing is like, whatever the lab do here, okay, I'll be doing in the same simulation tool. But if you come to this lab and you want to do that, you have to do it by your own, because the commands, whatever I'm going to use here, okay, the same commands you can use on the devices, actual devices. Okay.
Okay.
Yeah. Yeah, Cisco Packet Tracer. Okay. And this thing you can see it later. Just concentrate here, the below part. Yes. So we have our favorite devices. Okay. You can see here the networking devices. In that we have routers. We have a different version of routers. Okay. You can use any. And then you have switches. There also we have some different like L2 switches, L3 switches. Okay. And then we have a hub, and then we have wireless devices, and then we have security and WAN emulation devices. Okay. So actually we don't use firewall and WAN emulation because we don't have any kind of a practical in this CCNA. Okay. We can use only wireless devices, hub only for once, that I'm going to use now. And then we have switches. A lot of the time we use switches and routers. Okay. After that we have the end devices. Okay. And most of the time you are using PC or laptop. Nothing more than that. Okay. After that we have the cables. Did I explain the cables? Explain the cables. I did it, right? Straight through, crossover, console. I did. Okay. Same thing you can see here. This is a console cable. Okay. We don't use it here. Okay. Next we have copper straight through. Next is copper crossover. Okay. And if you don't know which cable how to use between those devices, you can go with the automatically choose connection type. Okay. It will choose you the correct cable. Okay. When you use a straight through cable, to connect the unlike devices or different devices. And when we use this crossover to connect the same devices. What is a console cable? It is used to take the control of the devices directly, physically. Okay. Okay, I'll show it later. So this is what the Cisco packet tracer what we are going to use. Okay. Now, what I'm going to show, how to take the devices and how to connect them and how to give the IP addresses, the basic part, and then we'll go for the next thing. Okay. We'll see how, like I always said you, right, how hub works and how switch works. Yes, I did. Okay. So practically we'll see. Practically we'll see that does the hub broadcast all the packets or Arun sir was lying. Okay, let's see. First, I'll take a hub. So what is a hub, Shah? Mhm. Hi, Pratik Babu. What is the hub? विसरला कसं काय? Layer 1, layer 2. Yeah, it is down. Other than that, just tell me something about that.
I used to communicate private device. We used to communicate one to other. So we connected to our node PC to communicate or share data and broadcast the data. Now we are not using.
You are not using it.
Not using. No. Yeah.
Okay, if I open this, if I open the hub device, can you see any kind of configuration? Is it allowing us to do any configuration? No, because it can't understand anything. Anything means what? Anything. It can't understand IP address. Okay, MAC addresses also. Okay, so that's the reason we don't have any CLI of that. CLI means what? Command line interface. Okay, but if we click on this PC, here it will allow you to assign the IP addresses, because to make these devices to be in the network, you have to assign the IP addresses. Okay, so we have here two methods to assign the IP address. So one is like you just go to config and go to faster than 0, and here you can give the IP address. Okay, that two type we have, two methods IP configuration. One is a DHCP and second is a static one. What is DHCP? Dynamic host configuration protocol. Okay, so where the IP address will be automatically assigned by the DHCP server. Okay, so static means what? Manually you are giving the IP address, and the same thing I want to do it now. Okay, now I'm going to use my favorite, that is 10.1.1.1. Okay, did I give, once I said tab, okay, automatically it took the subnet mask. That is exactly 255.0.0.0. How come? How it is? Because the network I'm using, that is a 10.0.0.0. According to that, the default subnet mask will be 255.0.0.0. Okay, now close this and go to the second PC. And one more method is like go to desktop and IP configuration. Here we'll be having some same information here to give manual and DHCP. Okay, so here I'll give 10.1.1.1. Can I give 10.1.1.1? If I give, what it says? It says that this address is already used in the network. Okay, if you want, you can give any other network. Okay, I give 10.1.1.2. Next, I'll go to the third PC and I'll try to assign the same, that is IP address 10.1.1.3. Okay, and I'll go to the fourth one and desktop. No, that we'll discuss. Don't worry. We have a separate protocol for that. Okay, so what if we do we have any DHCP server in this scenario now? No, right? Then in that case, what kind of IP address it will get? That is something different part. We'll discuss it. Okay, 10.1.1.4. Okay, done. Understood? Now I'll go to the simulation. Yes, I said you right. Whatever the packet a hub is getting, every time it is going to broadcast the same packet to everyone except from where the packet is getting received. Okay, for example, now I want to ping from this PC0 to PC3. I want to make the communication between this PC0 to PC3. Okay, we call it as a ping. Ping is a tool that is used to check the connectivity between the devices. Okay, how to use that one? Let me show you. PC0 and desktop and command prompt. Okay, you will get a beautiful black color window. Okay, and this is what you have to deal with every time. Being a network engineer, you have to see this beautiful black window. Isn't it cute? Okay. So just say ping, and next you have to give the destination IP address to which you want to ping. Okay, that is 10.1.1.4. Okay, if I say enter, it will be giving you reply. 10.1.1.4 will say that yes, I'm here in your network and we are able to communicate with each other. Okay, it says like reply from 10.1.1.4 and bytes is 32 and time is, it is just taking less than 1 millisecond. Okay, and TTL will discuss it later, don't worry. Okay, now we'll go to simulation mode, and I just want to make the communication between this PC1 and PC2. Okay, so for that I'll just take a packet, click on this one, this will be my source and this will be my destination. But immediately this PC generated two packets. Okay, the first one is a ICMP packet and second one is a R packet. Okay, you can see here. The first packet is type is ICMP and second type is what? R. So I think I explained what is R, right? What is R? I know it is address resolution protocol. What it does? Sorry? Destination IP address? No? MAC address? कुछ ऐसे कुछ बताया था मैंने? I said the same, right? When this PC1 asks like, is there anybody who is having the IP address like 10.1.1.3 in the network? Okay, I just want to talk to you, but I don't know where exactly this 10.1.1.3 is located in my network. Okay, for that reason, what it will do, it will hold that ICMP packet because it doesn't know MAC address. If I open this ICMP packet, you can see here, it is having only layer 3 information. Because I said like, you just ping 10.1.1.3. So that's the reason it is having the information like source IP as 10.1.1.2 and the destination IP as 10.1.1.3. It don't have any kind of layer 2 information. Layer 2 information means what? MAC address, because you already know that MAC address works in data link layer and the IP address works in network layer, and it is having layer 3 information, that is nothing but the network layer information. Okay, but it doesn't have any physical address information. That's a MAC address information. Okay, for that reason, what it will do, it will generate a ARP request packet. Okay, you can see here, this is what the ARP request packet is. Let's open that packet. What it is having now? Now this is having 2D70. 2D70 is nothing but what? Its own MAC address it is. You can see that. Can you see the faster than faster than 0 at the end? MAC address is there. 2D70. Okay, so this is what the source MAC address. 2D70. Oh, what is this one? What do you mean by this one? 12Fs. What is the size of MAC address? MAC address size. Size of MAC address? No. 48 bits. And how it will be represented in 12 number of hexadecimal numbers. Okay. So what is the highest number in hexadecimal number? 15. We write it as F. And what is the maximum number in IP address in IP version 4? 255. Okay. What is the broadcast address for all this 4.3? 255.255.255.255. This is broadcast. We are getting maximum number just to broadcast the data. Okay. Here also we are using the maximum number to broadcast the same packet. Getting my point? This 12F means what? This is called as broadcast MAC address. What it is? It is called as what? Broadcast MAC address. Clear? So here also it is having source IP address 10.1.1.2, destination IP address 10.1.1.3. Okay. And close this one and forward the packet. Which packet goes? R packet goes. Okay. So do you think the hub is going to broadcast the packet or it will be sent only to this PC2? Sure. To everyone? To this PC0, PC1, PC2, PC3? Except PC1, it is going to send it to everyone. You can say the same thing here. But you know that the PC devices are really intelligent. They can understand MAC address. Okay, they will check what packet it is getting. Okay, if you check it here, this packet was for 10.1.1.3. What is mine? This PC0 says that this is not for me because my IP address is what? 10.1.1.1. So this packet is not for me. So I'm going to drop this packet. Okay. And the same thing you can see on the same PC3. It is dropping the packet because that is having the IP address as what? 10.1.1.4. Okay. But if you see this third PC, that is accepting that one because the same packet was destined for the third PC. Okay. If you open that one, that will be creating a ARP reply packet. Okay. This is what it got. This is what it got from the PC2. That is 2D7D was the source MAC address and broadcast MAC address at the destination MAC address, and then it was getting from 10.1.1.2 and destination for what? 10.1.1.3. Okay, but once it reached the third PC, okay, it will be giving the ARP reply packet where it will be having its own MAC address as a source MAC address, and from where it got the request, that will be the destination. You can see here B984. Let me show you that. What is the MAC address of this one? B984. Okay, so that will be what? That will be what? Source MAC address, and 2D7D will be the destination MAC address. Now here also you can see the change. Here if it was the source IP address was 1.2, now it is 1.3 because now it is going from third PC to the second PC. Okay, so I'll forward the packet now. So do you think hub is going to broadcast the same? It is our packet, but it doesn't have any kind of broadcast. Is it broadcasting? It was only sending to 2D7D. Okay, but once I forward that one, it says that if you open the packet, okay, what you can see? Only layer 1 information you can see because hub doesn't know anything. It says that I don't know who is IP address, I don't know who is MAC address. I only know broadcasting. Okay, and it says like I'm going to do the same job at any time. Okay, so do you think it's going to broadcast now? Yeah, it says that I'm going to send it to fast Ethernet 0, fast Ethernet 1, and fast Ethernet 3, except fast Ethernet 2 because it is getting Yeah, it is receiving the message from the same fast ethernet 2. Okay, you can see that again it broadcasted. Yes, now again this PC1 and PC4, they are denying it to receive that packet because it was not for them. And now the ICMP was on hold. Yeah, it was on hold, right? Now if I open that one, it will be having the late information. Okay, this is how the devices will resolve the MAC addresses with the help of this ARP protocol, address resolution protocol. First, they will generate the ARP request packet. Okay, against that ARP request packet, the destination device will reply with the ARP reply packet. There it will be giving their own MAC address. Understood? Like that, they are going to learn the MAC address. Clear? Now, if I forward the packet, now ICMP packet will goes because it already learned the MAC address. It goes. Okay. Now, do you think it's going to broadcast? Sure. Yeah, even the hub will also say the same thing. It says that I'm going to broadcast to 0, 2, and 3. It does the same thing. And they already know that. What? PCs are intelligent, not like dumb, like this hub device. Okay, they can understand IP address, they can understand MAC address. So based on that, they are going to allow or deny the packet. Am I clear? So is it true? This is what I said when I was explaining about the hub. Am I clear? Okay. Now we'll just replace this hub with a switch or collision you want. Nothing is there. I'll take 2 devices. Okay. At the same time, again 4 packets are generated, one for ICMP, one for R. Okay, there it goes. Collision happened. Okay. Same collided data will be sent. That's not a see. It is not working properly. It should not send it to everybody, right? It is sent. Okay. This is what the collision is. It's not replying. Okay. Because it got the collided data. Yes. So that's the reason it is not replying. Clear? Any doubt in hub? No. Sure. Okay. Online? Any doubt?
No, I'm okay. Thank you.
Okay, when you are connecting initially, you will not get this interface number. Whatever the fast ethernet 0/4, fast ethernet 000, whatever the number you are getting here, you will not get it. Okay, you may get confused. For that, you just go to option, okay, and preferences. Yes, there's an option called always show port labels in a logical workspace. If you just uncheck this one and close this, you can able to see all the interface numbers were gone. Okay, if you want them back again, check it again. Okay, they are back. Yeah, they will show you the port numbers. Okay, I know that you will face the same problem when you start this one. Okay, you may get confused what the interface it is. Okay. Sorry, it is recording. I'll show the MAC table. Okay. So before that, I have to explain some of the modes in the CLI. Okay. So if you go to the configuration, this switch will not allow you to give any IP address. Can we assign the IP address to the switch? Can we assign the IP address to switch? दे सकते हैं? पक्का? क्यों नहीं अलाउ कर रहा फिर अगर दे सकता है तो? नहीं दे सकते हैं ठीक है. Now we'll go to the okay, this is what the CLI. What is that? CLI. What is CLI? Command line interface, which will allow you to configure the devices. Okay. Now, here we have 3 modes. Okay. Remember these 3 modes. Whenever you open the CLI, the first mode you will open, that is a user execution mode. Okay. Here very few of the commands will be worked. Very few. Okay. The second one is what? Privilege mode. Okay. Here some show commands and ping command and telnet command. Okay. And trace route. So these kind of, mostly this use this privilege command for the show command purpose. Next we have the main global configuration mode. This is a third mode we have in the CLI. First one is what? User execution mode. Second one is a privilege mode. And third one is a global configuration mode. Let's see what we have there. First, whenever you enter into the CLI, the mode you can see switch, greater than mark. Is that visible? I can't do that. Now, if I say question mark, okay, it will tell you like, what am I able to do? I mean, what you can do in this particular user execution mode. You can open a terminal connection, okay, disable, like turn on and off of this privilege mode, okay, and you can ping, you can show command, SSH, telnet, terminal, trace route. So very few commands are supported in this user execution mode. Now, how to go into this privilege mode from this user execution mode? There's a small command called enable. Okay, and if I hit enter, that will be into privilege mode. Okay. Is that okay? Now, if I say question mark, here also very few commands are supported. Okay, these are all show commands. Okay, and then now we can go from this privilege mode to the global configuration mode. So how to go? You just need to say configure terminal, and always take a help of your friend, that is tab. If you don't know what exactly the spelling of that particular word, what you want to type, you just type conft. That will also work. Okay, and if you want to make it full, just give it as a con and hit the tab. It will auto complete the configuration. And if you don't know what to do now after this, okay, you can use the question mark. That will help you what you can execute here in this mode. You can see here everything you can execute in this global configuration. Okay. Now do show MAC address. Can you see any MAC addresses here? This is what the MAC address table I was talking about, where we'll be having the VLAN information, MAC address, type, and port. Okay, can you see any MAC address here? No? Okay. See, I'm not going to send any kind of data from one PC to other PC. Okay. You can see there I'm not even pinging any other PC. If now I say show MAC address again, it learned. How? Did I exchange any traffic between the PCs? No, I didn't exchange. But how come it is showing the MAC addresses? Yeah, it can. But there should be some exchange of traffic, right? Then only it can learn the address. Till then, if it is like that, then initially it should learn it, no? it was totally empty. Now how come it learned the MAC address? Because we have a we have a protocol called GARP, gracious ARP, that will allow us to, when I assign the IP address on this PC as same 10.1.1.1, it says that it has already been used. So how come it is? How came it came to know that there is one more PC which is having the same IP address? Because of this GR. Okay, that we'll discuss it later. Understood? We have a separate again topic on that one. In that we are going to learn how exactly the ARP works in switch, okay, in router, okay, and different type of the ARP we have. Okay, there we are going to learn everything. Now, how switch works? It's a layer 2 device, I know that. I even said like switch will broadcast the first packet. After that, it will unicast the packets. So let's see the same thing. So this is my source, this is my destination. Again, it generated the two packets. One is ICMP, second one is a not GRP, I guess. ICMP, okay, from where it is going? 1.2 to 1.3. Okay, it doesn't have any MAC address information. For that, what it has done? It opened the one ARP request packet. So there it is having broadcast MAC address. Okay, just close this one and forward the packet. So do you think the switch is going to broadcast the same packet? Yes, it does. Open the packet. You can see there. It is broadcasting. Okay, in layer 1, you can see where it is sending it. It is sending it to 0/1, 0/3, and 0/4, except 0/2, because from where only it is getting the receiving the data. Okay, you can see there. Now it broadcasted, and you already know that PCs are really intelligent. They can understand what IP and MAC addresses. So that's the reason. Wait for it. Okay, so PC0 and PC3, they just denied to receive that packet, but the PC2 does. Okay, and because that was destined for the same, and for that ARP request packet, it created one ARP reply packet. Okay, so there it will be giving its own MAC address, okay, as a source. Now, if I forward that packet, so do you think it will be broadcasted again? No, it will not, because it already know that where exactly this 2D 7D is connected. It will check its own MAC address table. Okay, where 2D 7D is connected to fast Ethernet 0/2. So that will be sending the same packet to the same interface. Okay, so that's the reason I said like only for the first packet it is going to broadcast the packet. Okay, after that it will be sending every data packet in the unicast manner. Same thing you can see here. Again, now ICMP got the MAC address table here. Okay, now everything will be unicast, not any broadcast. Yes, I forward this directly. It will go to PC2, and again I'll forward it. It will go to the switch. and from there it will go to the PC1. Clear? Am I clear? Sure. Online? Any doubt?
Fine. No.
Mr. Pradesh, Vaishnav?
I'm fine. Thank you.
Okay. Now we'll start with the protocol. That is VLAN. Okay. Virtual Local Area Network. Okay. Let's suppose we have a building. We have a building. Okay. In that building, we have 4 floors. In each floor, one department is there. Okay. Let's take your favorite. HR, IT, sales and account. Okay. And I don't want this each department should talk with each other. Okay, talk means what? Like not like this communication, network devices. For example, if HR department wants to send any kind of data, okay, let's suppose like all of them are connected in the same switch. Let's suppose if they are connected in the same switch, okay, HR department also connected to the same IT and sales and the account. If the HR send any kind of a broadcast packet, then obviously it will be going to IT department, it will be going to sales department and account department. Then what is the use of security? Where is the security? Where is the confidentiality? Okay. So for that, what we can do? We can give a separate switch. If we want that should be secure, then you can give what? A separate switch for each and every flow. What happens if I give separate switch? That will be costly, because you know that one single switch can cost up to 50,000 to 1 lakh. Okay. Again, I have to spend 4 lakhs. Am I right? So it is kind of a thing like, let's suppose we have a room. Okay. In that room, one corner HR is sitting, other corner IT is sitting. Okay. Sales is sitting here and account team is sitting. And if the HR wants to talk with the account department, okay, without letting this IT department and sales department hear it, we can't do it here because they are in a same room. Obviously, if he is talking with the account department, this IT and sales also should be listening that. But I don't want that one. Okay, I don't want that particular data should be sent to IT department and the sales department. For that, what I can do? I can create some partitions here. What I can do? I can create the partition. That means whenever is this HR is want to talk with the account department, he can directly go into this account and he can talk. In that time, IT and sales can't hear that. Yeah. So same thing will be able to do the same thing in the switch. Okay. We are breaking this whole broadcast domain into some multiple broadcast domains. Understood? What is VLAN? VLAN is nothing but breaking this single broadcast domain into multiple broadcast domain. For example, if you are sending any kind of a broadcast packet, okay, let's suppose like we have this switch which is of 8 ports. Okay, let's suppose these 2 PCs, they are connected for the HR department, these 2 PCs IT department, okay, these 2 PCs for the sales department, and these 2 PCs for the account department. By mistakenly, this HR PC just broadcasts the packet. Okay, so obviously if the switch is having broadcast MAC address, then what it will do? If it is having destination MAC address as what? Broadcast MAC address, then it will be sending it to everyone. It will be sending it to IT department, it will be sending it to sales department, and it will be sending it to accounts department. That's what I don't want. That should only be sent to the HR department PC. Okay, so that's the reason what I'm going to do. I'm going to break this, not physically, but logically. What if I break this physically? 50,000 or 1 lakh, it's gone. Okay, so what we are going to do, we are going to break it in a logical manner. Understood? And that is called as what? Virtual LAN. Instead of creating a physical local area network, we are creating a virtual local area network inside that switch. Am I clear? Understood? So VLAN, it's a process which is used to break a single broadcast domain into some multiple broadcast domain. And how we secure the network with the help of this VLAN? You can see here. Different VLANs can't communicate with each other. Okay, if you see the same scenario, okay, it is having 8 ports. So again, HR department, IT, and then sales, and then account. So what I'll do, I'll just give separate VLANs for this. If I give VLAN 10 here, if I give VLAN 20, 30, and 40. If I make both of these PCs into VLAN 40, only they can exchange the data. This data will not be going to VLAN 30, VLAN 20, and VLAN 10 because we just broke that single broadcast domain into multiple by giving this different VLAN IDs and including those interfaces into those VLAN. Okay, so how we can restrict the data packet? Like different VLANs can't communicate with each other by giving or assigning those ports into some different VLAN. Okay, and by default, all the ports of a switch will be the member of VLAN 1. So VLAN 1 is called as what? Default VLAN. Whatever the switch port initially before making it to any other VLAN, okay, all those interfaces will be in the one VLAN. Okay, we call it as a VLAN 1. That is why it is called as what? Default VLAN. Understood? And some of the VLANs are reserved here. Like VLAN 0, VLAN 1, 1002 to 1005, and 4095 are reserved for some specific reason. Okay, where VLAN 0 is for Apple Talk, okay, and VLAN 1 is for what? Default VLAN and the native VLAN. And this 1002 to 1005, these are those. Okay, like FTDI default, token ring default, FTDI net default, and the TRNet default. Okay, we don't use this range because they are used for the internal purpose, internal switch use purpose. Okay, and the total size of this VLAN is what? 12 bit. 12 bits. So 2 raised to 12, 4096. 4096. Okay, so as you already know that we don't write it like that, we write it like 0 to 4095. This is a VLAN range what we use currently in our network. Okay, so this range is again divided into two types. One is standard VLAN, second one is a extended VLAN. Okay, so in that standard VLAN, you can see here the size of this VLAN is 12 bit and the range of this VLAN is again to 4095. And the VLAN ranges are divided into two parts. First one is standard VLAN, and the range is what? 1 to 1005. They just excluded 0 because we don't use that one. Okay, 1 to 1005. In that, these are the VLANs, they are reserved for some reason. VLAN 1, it's a default one. Okay, we don't use that one. And next is VLAN 1002, 03, 04, and 05. They are reserved for these reasons. Okay. And next is, if you create any VLAN in standard VLAN range, then the VLAN information will be automatically get saved in the VLAN.dat file into the flash memory of the switch device. Okay. I think I already said you like when I was explaining about the hub and switch, the hub doesn't have any kind of memory. Yes. So that's the reason it can't save any kind of operating system or even any kind of table it will prepare, just like the switch and router does. But this switch and router, they'll be having memories, flash memories, NVRAM or RAM. Okay, so there they will be having operating system and the required files just to run this device. Okay, and the same memory they'll be saving this, what do you call a MAC address table. Okay, in the switch, and in router it will be saving the routing table. Getting my point? So if you're creating any VLAN in the range of standard, what is the standard range? What is the standard VLAN range? 1 to 1005. Okay, if you're creating any VLAN within this number, then you don't need to save that one. The switch will automatically save the information into one database file that is called VLAN.dat file, VLAN database file. Okay, but if you are doing the same thing, I mean, if you are creating the VLAN in the range of extended, what is the extended range here? 1006 to 4095. Okay, so in this range, you have to save it manually. If you're using this one, you have to save it manually. Okay, with the help of some commands called write or do write or copy running configuration into startup configuration. Okay, so extended VLAN range 1006 to 4095, where VLAN 4095 reserved for some internal system usage. And if we create any VLAN in the extended VLAN range, then we need to save the information manually into the switch memory. Okay, and we can create the extended VLAN on the transparent mode of the VTP in case of layer 2 switch. See, we have a protocol called VTP. Okay, in that VTP we have three modes. One is server mode, transparent mode, and the client mode. And in server mode, client mode, we can't create this range VLAN 1006 to 4095. It is only allowed on the transparent mode. Why and all will be explained, discussing when we will be discussing about the VTP protocol. Okay. To save the VLAN information in the extended VLAN range, we need to use the command write, do write, copy running configuration, startup configuration. Okay, just to save this information. Now this is what about the theory part. Okay. Okay.
The VLAN ranges which you said, right?
Yeah.
10 that five numbers which you said, right, from 1000 to 1005. It is just 1000 to 1005. 1002 to 2005. Okay, it's not a range. It is only individual numbers, right?
It's individual number.
Okay.
Yeah. Those particular individual numbers, they are reserved for this reason.
Okay. So from 1006 to 4094 we can use.
No, in standard we can use 221001.
Oh, that number is also there. Okay.
Yeah.
Okay. Fine.
Yeah. Now what I'm gonna do, I'm gonna take this PC0 into VLAN 10. Okay. And that will be HR department PC. Okay. And this, I'm going to make it into VLAN 20, and that will be ID department PC. And this one, again, I'm going to make it into VLAN 10. Okay. That will be HR department. VLAN 20 again. Okay. That will be ID department PC. Okay. Actually, we are not going to add this PCs. We are going to add these interfaces into the VLAN, not these PCs. But those PCs are connected with the same interface, right? Then obviously they will be into that VLAN. Okay. Now I'll go to the switch CLI. Now which mode we are in? User execution mode. So how to go from user execution mode to privilege mode? Pratik, enable. Next, how to go from this privilege mode to the global configuration mode? Config terminal. Config terminal. Done. Now we are into global configuration mode. Before creating any VLAN, let me show you the VLAN database. Okay. Do show VLANs. This is what the VLAN database what we have. Is it visible? No? Now? अपना कल से यहाँ बैठो, ठीक है? When I say do show VLAN, okay, you can see there we have 5 default VLANs. I mean 5 VLAN numbers here. The same thing I said you, VLAN 1, VLAN 1002, 1003, 1004 and 1005. These 5 VLANs you can see by default in the VLAN database. Okay, same thing you can see here. 1002 to 1005, they are reserved for some reason and they are there in the VLAN database. One more is what? VLAN 1. And what is the name of that one? Default. And all the interfaces of this switch, it may be the fast Ethernet, it may be the gigabit Ethernet. So all are included, or all are the member of what? Default VLAN. That is the reason it is called as what? Default VLAN. By default, all the interfaces of the switch will be the member of VLAN 1. That's the reason it is called as what? Default VLAN. Yes, but what I want this fast Ethernet 0/1 should be into the VLAN 10, and fast Ethernet 0/3 should be also into the VLAN 10, and /2 and /4 they should be into VLAN 20. So how to make that one? We have to create the VLAN first. It is very simple to create a VLAN in Cisco. You have to just say VLAN. Okay. And if I say question mark, what is that? It is giving you the range 1 to 4094. 4094. And the ISL Okay, forget about the ISL for now. Okay, what VLAN ID you can use now? 121001. Okay, and that also 221001. Okay, now what I'll do, I just want two now, that is VLAN 10 and VLAN 20. So I'll just give it as a VLAN 10. Now if I hit enter, that will go into the sub configuration mode of that VLAN. You can see the change there. Can you? Before it was just config. Now it is config-VLAN. That means I'm into sub configuration mode. Before I was into global configuration mode. Now I'm into sub configuration mode of the VLAN. Okay. Now I want to give the name for this one, right? You just need to give the name. Okay. And what is the name? It should be John. Okay. Done. And exit. Again, I'm back into the global configuration mode. And one more VLAN I have to create. That is VLAN 20. Okay. And again, I have to give the name for that. Name is IT. Okay. Just exit. Now, if you say do show VLAN, there it goes. We created two VLAN 10 and VLAN 20. And the name are like HR and IT. Clear? But still, any of the interface is not added into these two. How to add them? We'll see it now. But before that, you have to learn something. What is that? We have two port modes here. In VLAN, we have two port modes. What are those? Access and trunk. What is access port? What is trunk port?
Sir, we will run that both ports so that it will be data transfer will be easy. There will be no redundancy.
Access means what?
That port will be assigned to that.
Access port means what? This is a port where it will carry the same VLAN interface, sorry, information. Okay. And trunk means what? Obviously. Which will carry multiple VLAN information. Am I clear? Okay. Access port means what? The particular port which will be carrying the only one VLAN information. Single. Okay. And trunk port means what? Which will be carrying the multiple VLAN information. Now tell me what these ports should be. They should be access port or they should be trunk ports? Trunk port. Sure. Access. Access. Sure. What is access? Trunk. Okay. Just give any answer. Don't worry, I'll explain. Access.
Trunk.
Trunk. Okay. Trunk. Trunk. Okay. There should be access. Why? Because I already said to you that whatever the PC which is connected to that will be generating the traffic of VLAN 10. And here VLAN 20, VLAN 10, VLAN 20. They are specific for one VLAN. It is not carrying multiple VLAN information. Okay, so that's the reason all these ports should be access port. Okay. Are you writing this one? No? Okay. Now, how to make them as an access port? First, we have to go into the interface. Okay. Because anyway, we want to make them into the VLANs, right? Okay. First, we have to go into the interface. How to go into the interface? Interface, if I say question mark, okay. So what is the type of here? It is a fast Ethernet. Okay. So just say fast Ethernet and hit the tab. What is the number there? 0/1. This is a port number. Just hit enter. Now we are into that particular interface. It says like if. Okay. Now I have to change the switch port mode here. Okay. For that I'll say switch port. If I say question mark, okay, it will be giving some different option. Now I just want to change the mode here. Mode, if I say question mark again, it will be giving you 3 options. One is access, second one is dynamic, and third one is a trunk. Access means what? Which will be carrying only one information, VLAN information, and second one is the dynamic. Dynamic, we have a separate protocol on that one. DTP, we'll discuss at that time. Next, we have trunk. That will be carrying the multiple, but we want to make this as what? Access port. So that's the reason I just say it as a access and done. Now we've done this. I mean, we made this interface as what? Access port. Okay. Now we have to say this port as what? Which VLAN you have to be into. Which VLAN you have to access. Which VLAN you have to allow to go through you. Okay. So how to tell that? Switch port access VLAN 10. I said this interface like you have to access only VLAN 10 information. That's it. Okay. Just hit enter. And if I say exit and do show VLAN, there it goes. Before the faster than 0/1 was into default VLAN, now it came into VLAN 10. That is HR department. Okay. Same like that, we have to add fast Ethernet 0/3 also into this VLAN 10. Okay. So interface fast Ethernet 0/3, switch port mode access and switch port access VLAN 10. Okay, what I have done? What I have done? First I made that interface as what? Access port, and then I said like you have to allow only VLAN 10 information. That's it. Okay. You can see there fast Ethernet 0/3 also got included into this VLAN 10. Okay. Now what I have to do? I have to make those /2 and /4 also VLAN 20. Okay. Interface fast Ethernet 0/2, switch port mode access, and then switch port access VLAN 20. Exit interface fast Ethernet 0/4, switch port mode access, switch port access VLAN 20. Done. Exit. Do show VLAN. There it goes. Both the interfaces are added into VLAN 20. Okay. Yes. Now if I ping 10.1.1.2 from the first PC, do you think it's gonna ping? I want to ping from this PC to the second PC. It will not. Sure. Are you sure? Let's check. It says that No, I'm not able to communicate with the 10.1.1.2 because that is in different VLAN. Okay, so I'm not able to ping that one. Okay, but what if I do with this? I mean, ping the same to the third one. Do you think it's gonna ping? Sure. Yes, it does because they are in a same. Clear. What about fourth one? Request timed out. Yeah. It says that I'm not able to connect to the last PC because that is into VLAN 20 and I'm into VLAN 10. And you already know that different VLAN can't communicate with each other, but the same does. Okay, same thing has been happening here. First PC is into VLAN 10 and second PC is into, sorry, last PC is into VLAN 20. So both are different VLANs, so they are not able to communicate with each. Am I clear? Is it correct? I mean, did you understand it? Sure, everyone? Come again? Don't worry. We have other protocol for that. Just for, I mean, just to be wait. Okay. Have patience. There we have inter-VLAN routing. Okay, we have to do the routing there. Understood? That will also I'll teach you. Don't worry. Okay. Don't be in hurry. Yeah, online. Any question? It was very simple one.
No.
Mr. Pradesh.
Yeah, I'm okay. Ideally, we are not using VLAN 1, right, which is by default. You changed it to 10, 20, 10, 20, right?
Yeah.
So by default, when we get one, it is by default that setting is there.
Yeah,
So idea is to change that one, and we shouldn't be using, right? One is like shouldn't use or we should use?
We don't use.
We shouldn't use, right?
Yeah.
It is okay, understood. Like the reserved one, right?
Yeah, it's a reserved one and it's not secure one because
Okay.
we already know that all the interfaces are
Correct.
included in the same. And if the attacker gets the access of that VLAN one, he can able to get the access of every interface.
I understood now.
Okay.
Got it. Thank you.
That's the reason we changed the VLANs.
Okay, got it.
Yeah. Okay, then we'll end it here today. Okay. So tomorrow
Sure.
we'll meet at the same time. Till then, everybody.